Okay, well, so SQL Schema Design.
Click on that Andre's website.
What's that?
The schema design.
Which one?
Third one down.
This thing?
Yeah, it's like SQL for YouTube.
Oh, yeah, sure. I know what you're talking about. Man, this was going away. Go away. Okay, so the important bits about SQL Schema Design is being able to think about a problem and the data that models that problem and the relationships between the different parts of that data, right? So if we were going to write our own software for tracking like the sales at a coffee shop, right? If we weren't going to buy something off the shelf, we'd have to come up with a way to, we'd have to come up with an app that let us do the things we wanted to do and then track the data or the state that we want to track, and then also be able to answer the questions from that data, right? Ultimately, the most important part about a SQL schema design is that it's able to answer the questions that you want to ask the database. So you want to drive your schema design by, at least I find it helpful, by like what are the questions you're going to ask, right? And what are the actions that you need to record, right? So if we're going to talk about a coffee shop, we need to like record a transaction or a sale. We need to be able to ask like how many sales were there in a given day. And I'm just making this up, but you can imagine like as you're given tasks on a project, like or features for a website, there's going to be a smaller version of this, right? If I'm asking you to add like a live, you know, well, that's too complicated. But if you're being asked to add like, it's a good example. I can't think of anything good.
How much of a specific type of coffee was sold?
Well, I just mean I was going to pick a totally different thing. Like, let's say you're working at LinkedIn and they want you to add a component to like the profile page that's like, you know, poke your friends, right? Let's say LinkedIn is copying the Facebook poke thing, right? We need to be able to add a part of the database to our schema that is going to persist the state to back that action, like who poked who, was I poked, did my friends poke me, you know, those sorts of questions, and be able to model that and persist that data. So I'm going to do this coffee shop analogy thing, but this should be a process in which you can apply to just also a subset of a website and not just a whole app, right? So you want to start by listing like the actions and questions, and we might separate these out. Let's separate these out. So the actions, I need to record a transaction. Here are the questions I need to ask my database. How much did we make today? Let's see. We want to, and then part of recording a transaction. So now we need to model. We need to start modeling what these what these things mean. Like, are we going to call it a transaction? Are we going to call it a sale? Let's call it a sale. So we want to record a sale. And so we need to kind of think of, if we're using SQL, most often you're going to make each table model some real world object. This is not always the case. There's a lot of reasons to use tables for other things, but in this case, like, we just want to keep a log of every transaction that happened, right? So we want to know what that thing is. What the hell's that? So let's talk about a sale. Might be a model that has like, it's definitely going to have an ID. I'll do this in SQL. It's going to have an ID, which is going to be a number that or an integer that is going to be a serial primary key. This isn't the right syntax, but I'm just kind of spitballing it. And then what else does a sale need to have? It needs to know, like, we need to have some sense of like, I'm actually not going to get to SQL just yet. Let's just let's keep this as just an object. So it's going to have an ID that's going to be an integer, and it's going to have like items maybe that'll be an array. of like the items that were sold. That would be a nice way to model this data. And then maybe the total, which would be money in cents, integer as money in cents, yeah. And then what else do we need to know about tracking a sale for a coffee shop? We just need to know how much was sold.
How much coffee is taken away from storage?
Well, that'll be listed in items. And we could build something else on top of that. Like, does the sale of an item mean it depletes some resource? We could model that too. There might be some sort of tip amount in here that we want to track. We want to know like the salesperson maybe, and this will just be an employee. Can anyone think of anything else we might need to model? So we know that now we're referencing items. So this is going to be a sale. And we know now that we need some sense of an item, which is also going to have an ID and maybe a description.
Would sales tax be the database or on the front end?
Sales tax? Oh, like the total, and maybe we'll store the tax. Although this is derivable, right? Isn't it? Or maybe we don't know what state we're in or something like that. Or let's just say let's store sales tax, sure. It doesn't hurt to store things even if we can derive them, but generally we want to try if we can to derive data that we need. There's also another model in here called a user or an employee. So our tracking system needs to know like who employees are. And this is not a real syntax, right? I'm just pseudocoding this stuff out. So does this stuff make sense where I'm just trying to list like the property and then what kind of property it's going to be? Yeah. Cool. Is there anything else we can think about that we need to track this, right? Here are the questions, right? Who sold what items?
You could add to items, maybe like how much is in stock.
Yeah, how many, stock, current stock of all items, yeah.
If you're expecting like a bunch of different states, would it make sense to keep your sales tax on a separate table so that you can join it per state?
Sure, if we wanted to get into that where it was like we had a system, we're doing this checkout system and it's gonna automatically calculate the tax and we just tell it what state we're in, we can do that. That's going to make this problem a little bit more complicated. I kind of want to just deal with a couple of tables. So I think let's just assume sales tax is simpler than it is in that. And maybe we won't even model it. We'll just talk about the total that was sold, the items that were sold. And this will probably not just be the items, but it'll also be like, let's make this like an array of like item ID, so this will track like the item ID that was sold and then the like number or like just the count.
Not the name.
Just the item ID because it'll link to the item name and description, and so we don't need to store that in two places, right?
Right. Because we didn't have it. So
We didn't have it. Yeah, totally. But yeah, like the fact that a sale has many items for which it's sold for, right? And then this can also be like the total cost of just the amount of these items, right? So this item down here probably actually needs a cost, right?
So I have trouble with that. Like why would you put that in the item itself, not in the sale?
Because in a sale, in a given sale, we don't change the cost of items for every sale. They stay the same. So our database knows we've got, so here, we've got a latte that's costs $4. And so that's just one item we sell. It's a small latte for $4. And this sale just references, okay, we sold a small latte. That's the item ID. We sold 2 of them to this customer. And maybe we don't even need to subtotal it there. That's all we need is to say like, here's where our items are, and then here we just reference those unique items, and then we've sort of separated those data, right? Because if we put that data in the sale, we'd have duplicate data if it was storing the cost, right? And it may actually be appropriate to store the cost in this sale item record here, because the cost might change, right? So maybe I want to store the fact that this item's cost was at the time $4 when we sold it. That's probably good historical accounting. So I don't mind that duplication of data, but we'll copy that over when we make the sale. Yeah. So how many sales were there in a given day? How much did we make today? Who sold what items on a given day? The current stock of all items. How many of item X did we sell on a given day? This seems like a fairly good set of questions. We probably can't get too much more complicated than this. So let's do a schema thing. So let's call this our items table. And this is just going to be the name of the item, and we'll make this a string, which will be a varchar. Why is that here? Oh, that was weird.
Yeah, it changes colors based on.
I see. That's fine and default. And no. Okay, great. What do I scroll down or something? How do I get out of that? Oh, and then there's already a name. I see. This is going to become description, and this will be text. Okay, so we have the items table, name, description. Item also needs a cost. So how do we add a column to this? Add field. There we go. Cost, and this will be an integer. And it cannot be null. And it defaults to 0. Didn't I just name this cost? Great. Oh, I have 2. Why do you delete it? This tool is weird. And you're an integer. Great. Okay, so we now have items. I want to remove these foreign keys. How do I remove foreign key? There we go. Okay, great. And then we also need an employees table. And employee needs a name so far. And so you just have a name and an employee ID. I think that's all you need to track your employees. Okay. And then, so now we just have like these two things. Why is this like linking to itself? Okay, so this just sort of stores the current state of things. Like if we have a new employee, we add them. Maybe the employees table needs a field at some point to be like, are they an active employee? Because we really never want to delete them, right? So we just want to store a set of who works here or who has ever worked here. And then we want to store any item that we've ever sold, because we need to keep this in here for historical purposes. So maybe we'll come in here and change the cost of items, but right now with just a simple table like this, we won't be able to store like history of cost of items. So if we wanted that, we'd have to get more complicated. Maybe every time you change the cost of an item, you make a new item and it has like a new ID, but it's still called a small latte. You know, so maybe at some point in this items table, we might actually also need active or maybe for sale or something like that, or available or something like that, right? To decide going forward. So is this helping how I'm thinking through this problem and how I'm just kind of, nothing solidified now. I'm just sort of thinking like, and it comes with practice, like I know I'm going to need to ask these questions, so I need to add these fields or I need to add these tables to be able to make it possible for the database to know be able to answer those questions. So right now, with just the items in the employees table, I'm able to ask these questions, right? Like, who works here now, right? That's good. I'm going to be able to do that by looking at the employees table. Can anybody suggest what the query to the employees table would be to say who works here right now?
Select all from employees where active equals true.
Yep. Select star from employees where active equals true.
And you have a typo for your table on the website.
Great. Okay, so then let's see. Which items are available now? Right?
Yeah.
Same
thing,
deal.
Just with items.
Okay, great. So now let's talk about which items were sold on a given day. Obviously. Right? Can we answer that question now?
We'd have to add a date to the items.
Well,
Or
the items, remember, the items table just represent what's available for sale. They don't represent any sales at
Right,
all.
right.
So
We'd
we
have to make
can't
it a
answer
sales
this
table.
question now because we haven't tracked any sales, right? So I'm going to make this a sales table. And each sale will have a unique ID. And then I don't know how to use this tool. There we go. And so a sale will have a total, and that'll be an integer that's not allowed to be null. And then what else do we say a sale needs? The sales person, which will be an integer that is not allowed to be null.
salesperson should be a string.
No, salesperson is going to be
Oh, it's
a
gonna be their
reference to
The employee ID.
the employee ID. Yes. And how do I do that? Connect foreign key. Great. Sweet. So a sale connects to a salesperson, and that's the ID of an employee. And then we have a total, which is money. But we need this items thing. We need to know how many items, right? So this is where SQL gets a little bit tricky, because this is a reference to multiple things in another table. If each sale was only for one item, we could just add an item ID here and link it to one item. And then we could sell one thing at a time, right? But we need to sell more than one thing at a time. So a sale needs to have a link to multiple items. So we could do something like add multiple columns to the sales table of like item 1, item 2, item 3, right? But then we'd be limited by the number of columns we chose to put in that table. So can anyone think of another way how we might link multiple items to a single sale? No?
Linking multiple items to a
Yeah, how could we say that sale 1 sold items 1, 2, and 3? A join table. Yep. So we will make a join table. So we're going to call this sales or sale items or something like that. Sale items. I used camel case here, but the convention that I'm used to is underscore case. I hate that I switch back and forth all the time. But we're going to call this sale items, and we're going to add a field called sale ID. And we're going to add a field called item ID. And then we're just going to link sale ID and item ID. So now, if we want to ask the question, what items were sold, for sale ID, right? So let's say for sale 5, 6, 7, right? So we're gonna do, does anyone want to take a stab at this? So what items were sold for sale? within sale, whatever the ID is, it doesn't matter. Yeah? So a clue here is what items. That should tell you how to start this query. So how do we start this query?
Select ID from
Well, we'll get it all. Select star from
items.
items, great, because we're getting items, great. And then what?
Here's where you'd have to do the join.
Here's where we're going to do the join, yep. So select star from items, join sale items on
Sale ID equals ID.
sales.id is equal to sale items.saleid, where, what's the where?
Where
Items.
items.id equals the sale number.
No, because this is a sale ID, so it's this column here. But we can use this column here to scope down. So we say sale items dot sale ID is equal to that. So we're not actually even using the sales table here. We're just saying, give me all the items where inside this table there is an item that also matches this sale ID. So what it's going to do is it's going to go through this table and say, find me all the records for this sale ID, and then from that set of items, get me all the item IDs. So this is going to allow us to select an item, or select all the items for a single sale. But this join table is also going to let us select a specific set of sales, like an array of sales, and then get all the items for that array of sales as well. So we can sort of do this, this whenever you model something where you have like one record that has a link to many records, it's a one-to-many relationship, right? So we have a one sale to many items relationship here. So if you were to draw this connection here, like this connection between sale and items is like a 1:n. It's like a one too many. And I guess you could consider it actually as a many to many, because if you look at the relationship the other way and you say, I can actually ask, how many times did we sell a specific item? How many sales yesterday were there for a specific item? Right? So how can we write that query? How many sales were there that included item 54? How can we ask this query? So this should give you a clue. How many sales? That tells you how to start your query.
I think it's like count of or something similar to that.
Oh yeah, sure. How about how many is not what? How many is a good way to do it, because we'll do a count. But that we can always add a count. So let's just say which sales include item 54. So we want sales, right? So how do we start our query? What's up?
You do select all from sales or ID.
Yeah. Select star from sales, right? So that'll get us all our sales, and then we're using a join clause here, a join statement here to reduce the number of records we get back. So we're going to join on what?
On sale ID.
Well, we're going
Or
to
join on the sale item.
we join on tables.
Yes,
So which
join
of
on the sale items.
the sale items table, correct? So get all the sales where, and we're gonna do. We can actually just pause on the join part, and we can kind of do the beginning and the end of this query, right? Select star from sales where the item ID, so the sale items item ID is equal to 54. So we know we want this to be our condition, right? We only want the sales where the sale items item ID contains 54, but then the join statement, we have to join to that table, and what are we going to join on?
On sale items ID equals items ID. You could do
So the
something
sale
like that.
item ID, we actually don't even need this field. I'm actually going to remove it because it's a join table. I shouldn't have, it added it for me and I didn't think to delete it. But a join table, you can often see what a join table is because it doesn't have an ID, because each individual pairing of item to sale, these should probably be unique. There probably shouldn't be more than one, but maybe there will be more than one actually. But actually the way that we wrote it down here, we put a count. So we might add that to this row here. But we just want to link these to these. So we don't actually need an individual ID for that. So since we remove that, and that's no longer on the table for how we can do our join here, we want to say join sales to sale items. So how do these connect? Look at this blue line.
Yeah.
How do these connect? And that's where that foreign key connection there, that's what we should put in our on condition.
Okay.
Sales dot ID equals sale actual items dot the sale, well, this time.
That's sale ID, right? So the sale ID matches the sale ID. Just like up here, the sale ID matches the sale ID, right? So if you're going to join two tables, you join them by item ID to item ID, or sale ID to sale ID. Yeah? So that should give you a clue on how to do these on statements here, is that they're usually the identical same item, right? It would never make sense to do a join on item ID equals sale ID. Because you could get that join, but it wouldn't be sensical, right? It would be, those numbers would match up by happenstance, not by logical anything, right? So this should tell us all the sale records where there is a record, for all the records in this table, where there is a record that matches that ID over here that has an item of ID 54. So let's pause here because we've done two joins here, and I want to know if like going through this and answering these questions is helping sort of give you an idea on how to drive the design process here. Cool. So we have a little bit more complication that we need to add to this, because right now sale items, normally on a join table like this, I would put an index preventing you from having two records that are the same, right? We don't want to say sale 5 sold item 54 6 times. Maybe we do want to say that, maybe we don't, but we should consider it, right? Because that's one way we want to get a sense of a sale can have more than one item in it. We can sell 4 small lattes in the same sale. So do we want to do that by adding multiple rows of the same item in the sale items table, or maybe we'll add a column that says the count? What do you think, Monica?
I don't know. I don't have a big opinion on it.
Okay.
I had kind of a question. But
Yeah,
I
ask your question.
Oh, well, I was just wondering if like you could explain what an index is. Like I have a general idea that I would like to hear like.
Sure, an index in SQL does two things. It can significantly improve the performance of queries, but it can also serve as a constraint for what data is valid to go into a table. So, for example, in a unique ID, we should be familiar with, right? This is an auto-incrementing unique ID, so every time I create an item, the database tells me what it assigns an ID to that item. I could attempt to insert an item with the same ID as another item, but if I try to do that, the database will tell me that I've violated the unique constraint on the primary key column. Because unique IDs both have an auto increment function so that the database is the decider of what the ID is, and I'm ensured that I'm always getting a unique ID and I'm not going to have collisions, right? So we're taking advantage of the database being the centralized decision maker for that. But it's also making sure that you do not have two items with the same ID, because that's a constraint that we want to enforce in our data, because it wouldn't be useful to us. It would be very problematic if we had two items that had the same ID. So the database is going to use an index to both increase performance for queries that say, give me the item, select star from items where ID equals 5. It doesn't have to go through and look at every row in the table. It already knows which row has ID 5 because it stored that in an index. So those queries are fast. So the indexes on each of these ID columns here are actually used when we do a query like this, because we're saying join on sale ID matching sale items ID. So this has an index on it. So if we need to look at the sales, so for this query, the database is going to look at sale items, and it's going to find all the sale items that have an item ID of 54, and it's going to get that array of sale IDs, and then it's going to say select star from sales where the ID matches that array. And in that sub part of the query, it's going to be able to take advantage of that index, right? So just like the part of the query where it goes and gets the sales that match the subset of sale IDs that we have in this table, we also want to make it fast for the database to say this part of the query where sale items.item ID is 54. We want this to be fast. And right now, if we don't have an index on this sale items table at all, when the database needs to find all the records in this table that have sale items item ID 54, it needs to go through and look at every single one. So what we'll want to do is, if we're going to do any queries where we query this table by this column or this column, we want to put an index on those columns. And what that's going to cause the database to do is it's going to keep a separate set of data that says which rows in this table have this item ID in their value. So it can look in this essentially other table or other source of information, which may or may not be a table, but it's an index for the purposes of our thinking about this. Looks in the index and says, which records have item ID 54? And just give me back those records, and then it makes it faster to query back those records. So it doesn't have to walk through the table. So we'll put an index on these sale items. So if we if we started to write some of our, actually we might be, does this thing model indices at all? I don't see anything on here about indices.
Maybe not. I think it's very basic.
Okay, well,
you can like save out and it generates SQL for your schema, but I don't think it.
Yeah. Maybe edit table. No. Okay. Well, the way we would do this in SQL is we would create the table, and then as a separate instruction, we would add an index. So indexes are additional additions to a table, and they are optional. For the querying optimization, they're optional. For the conditional or for the constraint aspect of things, they're not optional. So if we want to say that you cannot put two records in this table that are identical, we don't want to add the same item to a sale more than once. The only way to put that constraint on this table is to add an index that says we're going to index sale ID and item ID together, and the order matters. We can do sale ID first or item ID first, and that has some differences on whether or not this index is applicable to certain queries. We'd have to read some documentation to get into that. It would probably work just fine for both of these queries that we've used up here. But if we put item ID, if we put sale ID first and item ID second, we may not be able to take advantage of that index for just item ID here. So we may want to do more than one index. But we're going to do an index for sale ID and item ID together and put a unique constraint on that index. If we were to do that, then in order to get total, we'd probably want to add some sort of count. Some sort of, I don't care what size, just close. Some sort of count on the link between the sale and the item. And that, so when we put our unique constraint, it's just on these two columns. So if we had a record in here that was sale 1, item 5, four of them. So 154 is what you'd see in this column. We could try to inject a 156, which was like 6 items for the same order of the same item, and it would reject that because even though the count is different, our index is just on these 2 columns together. Does that make sense?
Yes.
Any follow-up questions about indexes? I think it's indexes for databases.
Oh,
Don't-
for databases.
I don't know. I've seen it both.
Makes sense.
Cool. Okay, let's see if we can answer some more of these questions. Which items were sold on a given day? Can we answer this question with this database schema?
We tend to add the dates.
We would have to add the dates. Good observation. Cool. So a sale is probably where we want to add that date. So we're going to add a field called a sold at and make this a date time or a time. How about timestamp? And it can't be null. And it defaults to now. Great. So now we have when the sale was sold. So how do we say, oh, and then another thing, oh, we do have total on here. Okay, cool. So then which items were sold in a given day? How do we write this query?
It'd be like select total or select select ID maybe.
Yeah, let's just get the whole record.
Okay.
But where are we selecting from? From which
From
table?
sales.
Nope.
Or,
Which items?
sale items. Okay.
Nope. Not sale items.
Or just items.
Just items, yeah. So we want to know which items. So we want the whole item back. So select star from items. And then the one input that we have is going to be a date. So we'll just say 2017, 0801 today. So here's our date. So at some point we're going to say where sold at is equal to this date. And so we need this middle part.
You like to join?
We do need to join. Yep. So we're going to join what? So we're going from items to where?
Sale items.
Sale items. So we're going to join sale items on what?
Item ID. Equals, items dot ID equals sale items item ID.
Correct. Okay. So now, a good way to think about joins is that they take 2 tables and they create another new temporary table. And that is sort of a smashed together version of those first 2 tables. So if we forget this part, we just focus on this right here. If we just say select star from items, join sale items where item IDs match, we're going to get a table that has all 5 of these plus these 3 columns on it. So we're going to have a big table that says here's the item and then here's all the sale items that matched up to it. And we're going to have more than one. We're going to have duplicate items because they'll be sold on more than one thing, right? So we can try to visualize this if you want. So we can dump this into a real database and visualize it. But this query just right here without any where is going to give you a big table of duplicate items matched up with the sales that they were matched up on, right? So if we had 3 sales that and 2 of them sold lattes and the other one sold an Americano, then we're going to have latte, latte, Americano with sale 1, sale 2, sale 3, right? Does that make sense? Should we visualize that? Should we put that in a real database? Yeah. How do I export this thing?
Save, generate, SQL.
Oh, I don't actually want any of these references. Why is this not working? Oh, it doesn't like the way primary key is written.
Sometimes it doesn't like the quotes either.
Serial primary.
Yeah.
Comments on table. Line 31.
What is this SNM? Oh, we have a bunch of crap in here we don't need. Employees, items, sales, sale items. That's right. And then what is Postgres is like primary key serial? Isn't it that how you do it? Something like that.
Serial primary. I think it's yes.
What's up?
I think it's serial primary.
Okay. Well, I'm gonna try it anyway, but you're probably right. Yeah. I can never remember. Line 5. Oh, it just doesn't like this trailing shizzle.
Line 19.
There we go. Okay. All right. Employees is spelled wrong. Crap. It's like that, yeah. Okay. So let's do this. Let's say insert. I wish I could make this bigger. Can you read that? It's really small, yeah. Insert into employee, or actually items. Let's just write this over here. Insert into items. Anyone remember how to do an insert statement? I can never remember how to do it by hand.
It's like the like name and yeah, and then values.
Need a comma between cost and available.
Thanks. Okay, so latte.
Appreciate your use of an accent.
Available. Great. So let's just do house coffee. And we'll do an item that is not available anymore, which is like, I don't know.
Pumpkin spice.
Huh?
Pumpkin spice.
Yeah, there you go.
Pumpkin spice is always instead of quotes. Never true beliefs.
Sweet. Okay, now we need some sales.
You don't need that first row.
Thanks. So total and let's see, sales person and sold at. So let's just say it's $10. Salesperson 1 and sold at now. And this was $20. $15. Salesperson 2. All right. And then we need to insert into sale items. So the first sale, which I'm actually going to put the IDs in here. so I can reference them. Normally the database would decide them, but I want to be able to reference them in here, so I want to know exactly what they are. This is not a real world case. We would usually do this with code, do this dynamically. So then this is just sale ID and item ID. And doing this manually is also a problem because the item cost is not going to match up with the sale cost, but it would if we had done this programmatically, right? Cool. So then it's just going to be sale ID and then item ID. So I'm actually going to do the same thing up here. And when I'm doing this manually, I tend to do something like I'll try to like kind of put these in blocks just to help myself, right? So this is sale 10, sold, item 40 and 41, and then sale 11, sold 40 and 42, and then we'll do sale 12, sold 41, 42. Did that work? We got some items. Oops. We got some sale items. Nope. Got some sales. Nope. Comma. Probably need to get rid of this comma. There we go. Okay. So now we can use that query that we did up here, which was just select star from items, where items ID. Okay. So this is what we have in items, and then in sale, oh, it didn't, did I screw up inserting items? Yeah, I ran this query before I modified it and put the right IDs in there. Does that make sense? Does everybody see my mistake? So I'm just gonna go into items and delete all these and just re-add them. And then we will be able to do, great. So if we selected star, man, I wish I could make this size bigger. I don't know if this records me doing this, but it'll be good for y'all. Okay, so select star from items, right? Gives us that. So we have those 4 tables, or 5 columns. And then if we just join to items, now we get these other things. So we can see that ID and item ID are 2 separate columns, but they always match. And we can see that we have duplicates. We have latte twice and cookie twice. It's because latte was on sale 10, but it was also on sale 11. Does that help you visualize how a join smashes 2 tables together and allows you to sub-select from the join table? Cool. So now this question that we were working on, which is which items were sold on a given day, we need to add this sold at, but we don't have sold at, right? If we add that, we don't have sales. We haven't joined to sales. So we need to do a second join. So we're going to join to sales. And we're going to join on what? Does anyone know what the join's going to be to join to sales? So we've gone from items to sale items. And then we need to go to sales. How do we get there?
Sale items, sale ID with the sales table.
Cool, so now we have this even bigger table where we've smashed them all together. So we know that latte was part of sale 10, which is now sale. So this is sale ID, this is item ID. And so these 2 columns are from the join table, and you'll see they both match up. And so now we can add our where condition, which is, this is not how you format a date. So I'm just gonna copy this.
Because you did times.
I did timestamp, yeah. So how do we? So now we have to question. We have to, and I would look this up. Postgres. Where timestamp in given day or on date maybe from timestamp. Now I want to extract. Oh, I guess extracting it would be fine. So we could do this date trunk today. So here's an interesting tool. You can also add like derived selected columns. So you can do select star here, but you can also do a modification of sales sold at as sold on. And so now I have a new column that is derived from this column that I named sold on that is just the day of the thing. Does that make sense? So you could do something like count the sales ID as sales count. Well, actually, we'll count the items ID as items count. Should just be 1. Oh, I need a comma. Huh, items ID must appear in the group by. Okay, well then let's do a different one. We would need to group. Well, anyway, you see where I'm going with that? That you can sort of create these things. So so now I want to know, how do you do a where condition against that? Interesting. Let's try this one, this where condition here. So this would be the sales sold at, and if you do : date, I don't know if this is going to work. And then we'll put this in here and okay, cool. So we don't need this sold on thing because we just did this. I think this is like a type conversion. So it's like convert this column to just the date. And then I think this is probably a function that I don't know if this turns this into a date. Yeah. So it turns that string into a date. So all of our sales happened on the same day. So I'm going to come in here and change some of these sales to be on an older date. And now if we go do our query again, not work.
You didn't save them.
Oh, what? Thank you. Great. So these are all the ones on August 1st, and then July 1st, and then June 1st. So we sold. So now we have this query functioning. And then we are out of time. I hope that was helpful.
Yeah.
Thank you.
Thanks, Jared.
Sweet. We should do more SQL next time.
Yeah.
Be great. Was that just you? Yeah.